When you type in a domain name, DNS is what turns that name into an IP address, all in the background before a single packet gets moving. Think of it like ordering your favorite pizza by name instead of giving them the GPS coordinates of the oven. The domain name system isn't just one massive phone book. It's more like a network of mini phone books working together. No single server knows it all. Your query takes a little trip. Starts with your local cache, then hits a recursive resolver and heads over to root servers, moves on to TLD servers, and finally ends up at the authoritative server. Understanding this chain reaction is key if you want to nail your CCNA and Network Plus exams. First up, the client checks its local cache to see if it already has the record. If it finds it and it's still fresh, great, job done. Kind of like checking your fridge before deciding to go grocery shopping. But if the cache comes up empty, the client then calls on its friendly neighborhood recursive resolver. This is often provided by your ISP, or maybe it's a public one like Google's famous 8.8.8.8. If the resolver is also in the dark, it takes things up a level by reaching out to one of the root name servers. There are 13 clusters of these root servers, like the VIP section of the internet. The root server doesn't give the whole answer, but points the way to the TLD server for the domain suffix. Think of it as asking to see the manager and being directed to the assistant manager instead. Next, the resolver queries the TLD server, which then directs it to the authoritative name server. Finally, the authoritative name server hands over the A or TRIPRA record we've been hunting for. It's a bit like a digital game of telephone, isn't it? But it gets the job done. Picture this. You're craving pizza and need to know which number to dial. DNS records work in much the same way, mapping names to numbers to make sure your data gets to the right place. Records are your trusty friend for connecting host names to IPv4 addresses, while AAA records are your link to IPv6. CNAME records? They're like nicknames, redirecting one name to another, just like calling Robert by Bob. MX records act like the mailman's address book, ensuring your emails land in the right mailbox. NS records are your reliable tour guides, showing which name servers are in the know. PTR records flip the script, helping you figure out who's calling you from an unknown number. SOA records lay down the rules, holding critical information about the zone. And those TXT records? They're the sticky notes pinned to your fridge, storing text for SPF and domain verification. Let's take a journey with a DNS query for www.example.com and see how it navigates through its hierarchy. Picture this. The client kicks things off by sending a query to the recursive resolver. Think of this resolver as a detective on a mission. It starts by contacting a root server to get a hint, the TLD referral. Armed with this new clue, it reaches out to the TLD server, which then directs it to the authoritative name server. Finally, the resolver gets the answer and passes it back to the client. It's a bit like a relay race, with each leg running on UDP port 53. And despite all the detective work, this process usually wraps up in under 100 milliseconds, fast enough to give even a cheetah a run for its money. 5 common DNS traps you might trip over, so let's tackle them. First, DNS usually runs over UDP port 53 for its regular queries. But when zone transfers happen, or when you get responses larger than 512 bytes, it switches over to TCP port 53. Yes, you've got to remember both ports for your test. Now, about CNAME records. They can't point directly to an IP address. Imagine if you only knew the landmark next door and tried to find a specific address. You'd actually need another name to guide you. Third, PTR records are a bit tricky. They live in the inaddress ARPA zone for IPv4 and are written in reverse octet order. It's like trying to read your grocery list backwards. Fourth, let's talk about TTL, or time to live. This tells you how long resolvers can hold on to a record in their cache. A lower TTL means everything updates faster, but also means more traffic, like a fast food joint getting slammed at lunchtime. Finally, remember that it's the recursive resolver doing the heavy lifting of gathering data, not the root servers. The root servers are more like hotel front desks, just pointing you in the right direction. Keep these traps in mind, and you'll be breezing through DNS like a seasoned pro. So there you have it, DNS wrapped up neatly, from grasping the resolution hierarchy to knowing your way around record types and tracing the query path from the client to the authoritative server. Ready to put your skills to the test? Hop over to Courseiva.com and dive into some CCNA questions. You're ready for this.